Video on similar shapes, and we'll also include similar triangles. Similar shapes are an enlargement of each other. All corresponding lengths are enlarged by the same scale factor, and the scale factor is found by taking the image length and dividing it by the corresponding object length. The object is the shape with the lengths that you know, and the image length is the shape with the lengths you're trying to find. So in this example, we're trying to find x, so we'll be starting with the object, which is a length we know. That'll be the small can, and the large can will be the image. So the two corresponding lengths we have are 12 and 24. So from the small can to the large can, that's a scale factor of 2. And therefore, in order to find x, it's simply 5 centimeters times by 2, and that's 10 centimeters. Here we have a photo, and it's been enlarged to make a picture. So we're trying to find x in the enlarged shape, so that will be our image, and the smaller picture will be our object. So we're going from the small to the large. That's 14 to 49. So 49 divided by 14, that's 3.5. That's our scale factor. So from 8 to x, we're going to times 8 by 3.5, and that will give us 28 as our missing value x. In this example, the small glass has the length missing, that's x we're trying to find. So we're going to go from large to small in this case. So the scale factor from 10 to 8, it's the image length. The image in this case would be the small glass, so it'll be 8 divided by 10, and that's 0.8. Therefore, in order to find x, we're taking the 16.5, multiplying it by 0.8, and that gives us 13.2. For two triangles to be similar, all the corresponding sides have the same scale factor, and sometimes in a question you may be asked to check. So if we compare 4 centimeters to its corresponding length 12 centimeters, that's a scale factor of 3. From 3 centimeters to 9 centimeters, that's a scale factor also of 3. And from 7 to 21 centimeters, that's also a scale factor of 3. Therefore, these two triangles are mathematically similar. There are two other definitions of similar triangles. Two triangles are similar if all three angles are equal, as you can see on the left-hand side. Alternatively, on the right-hand side, if two corresponding sides have the same scale factor, I think we can see that the lengths from the small triangle to the large triangle have been doubled. If they have the same scale factor and the angles between the two lengths are both equal, as we can see from the diagram, the angle between the two lengths are both b, so they're the same. So those two triangles would be similar. So here's example 1. We're trying to find x, and in order to do so, we're going from the small to the large triangle. So we need the scale factor. So from 10 centimeters to 15 centimeters, that's a scale factor of 1.5. So in order to find the missing length x, we're going to use the 11 centimeter length on the small triangle, and it's 11 times by 1.5, and that'll give us 16.5 for x. Note, we're trying to find y on the small triangle as well. So we're going to go from large to small. We're going to use the 9 centimeters on the large triangle to find y on the small. And going from large back to small, we're going to be dividing by 1.5. And that gives us 6 centimeters as our missing length y. In example 2, very similar. We're going from the small to the large triangle in order to find x first. So from 8 centimeters to 16 centimeters, that's a scale factor of 2. In order to find the length x, we're going to use its corresponding length on the small triangle, which is 9 centimeters. We're timesing that by 2, and that gives us 18 centimeters. In order to find y on the small triangle, we're going from large to small, so we're going to be going back the other way, so we'll be dividing by 2, and that will give us 5.5 centimeters as our missing value for y. Sometimes we have a question where we have a triangle within a triangle, and I would advise you to redraw the smaller triangle outside of the larger one as follows. Mark on its lengths and vertices, and then in the larger triangle, let's get rid of the 7 centimeters, we don't need it, and the length 8 centimeters and 4 centimeters, let's just put together as 12 centimeters. Now we're trying to find CD, so that's in the large triangle, so we need to find the scale factor to go from the small triangle up to the large triangle, so from 8 centimeters up to 12 centimeters, and that would be a scale factor of 1.5. So in order to find CD, we're going to use the 7 centimeters in the small triangle, multiply that by 1.5, and 10.5 is our answer. Once again here we have a triangle within a triangle, so I would take the small triangle outside, mark on any lengths, mark the vertices, and then in the large triangle rid ourselves of what we don't need, and in the base there put the 4 and the 12 together to make 16. Now I want the length DE, which was in the large triangle. In order to do that, I first of all need DA, and I want the scale factor from the small triangle to the large triangle, so from 12 up to 16. That's a scale factor of 16 divided by 12, and that's 4/3. So now I'm going to use the 11 centimeters on the small triangle in order to find DA. So 11 centimeters times by 4/3 gives me 14 2/3 centimeters for my length DA. Now remember, it was DE, the length that I wanted, so when I place back the small triangle, we can see that DA subtract 11 centimeters will give us DE, 3 2/3 centimeters. Sometimes a question will look a little bit like a bow tie, and note, by the way, these parallel lines here at the top and this one at the bottom, that's really important. Let's try marking some angles that we can. First of all, those two angles marked in yellow, they're vertically opposite angles, so they are equal. I'll just mark them with a colour to denote they're equal. Then we have alternate angles, because we have parallel lines there. Those two angles that I've marked in green, they're alternate angles, so they're equal to each other. And similarly, the two angles I'm marking in there, they're also alternate angles, so they are equal to each other. So now we've marked in angles that are equal to each other, let's set about working out which are the corresponding lengths. And I've marked in the length PT there in pink. The reason is P to R on the large triangle joins up the blue angle to the yellow angle. Similarly, T to R on the small triangle joins up the blue angle to the yellow angle. So the 14 centimeters and the 7 centimeters are corresponding angles. Now it's always the case when your diagram is a bow tie that if you just join one of the crisscross lines in, just draw one of those lines in, the two parts of the lines are corresponding. So similarly, from Q to S, if we were to draw that in, which we will in a minute, QR corresponds to SR. Therefore, what's the scale factor from the large triangle to the small triangle? Well, as I said, the 14 centimeters corresponds to the 7 centimeters, so that's a scale factor of a half. Then if we join Q to S, remember QR is corresponding to RS, so the 16 centimeters corresponds to SR or RS. So 16 times by 0.5 will give us SR. Here in example 2, once again, let's work out which angles are which. Those two vertically opposite angles are equal. Using Z angles, the green angles that I've marked in are alternate angles and therefore equal. And another pair of Z angles or alternate angles, they are equal. Then if we join B to D or D to B, we can see that D to C joins the blue angle to the yellow angle. In the large triangle, B to C joins the blue angle to the yellow angle. So that makes BC and DC, they are corresponding lengths. Therefore, 20 centimeters on BC becomes 16 centimeters DC, and that scale factor 16 divided by 20, that's 0.8. So from the large triangle to the small triangle, we're multiplying by 0.8. Therefore, AC corresponds to CE. So from 18 times by 0.8, and that gives us 14.4.